Good morning, everyone. My name is Jackie Lau from Gowin Semiconductor. I'm glad to have the opportunity to give an overview of our DCSCM 2.0 implementation in Gowin FPGA. So first, I will introduce our LTPI implementation. We saw a demo in the experience center over there, and that demo used the GW2A18 FPGA with a LVDS link running at 200 MHz. The interface can turn on 16 low latency GPIOs and 48 normal latency GPIOs. It also turns 2 UR and 6 I2C. The next table shows the latency and bandwidth of the interface when they are turned on through the LTPI interface. The latency for the low latency GPIO is only 0.75 microsecond. The latency for the normal latency GPIO is 0.85 microsecond. For the UR link, the interface can run at either 9600 or 150 and 200 bit per second. For the I2C link, it can run at 400 kHz. The total resources utilization is in this implementation is about 2,000 lux. The working principles for the LTPI is presented on this block diagram. The traffic from the interfaces is captured by the LTPI controller. First, then the LTPI frame will be generated and together with the CRC trapped. Then the frame will go through a multiplier, and then the frame is being added with the comma symbol. Then it's being encoded to 10-bit encoding. Then the LVDS TSV will serialize the frame into the LVDS link. Then on the HPM side, the LVDS RSV will capture the frame from the LVDS link. And the frame will go through a data aligner. Then the frame is detected based on the common symbol, and the frame will be decoded into 8-bit encoding. The frame is checked against the CRC trapped and decomposed into the LTPI channel. To address the security problem, Gowin has secure FPGA ports, which provides a hardware root of trust based on SRAM PUF technology, So the key is generated when the power is up, and the key is never restored. The intrinsic ID block key pro security library is provided with the secure FPGA, allowing easy integrations of common security features into user applications. This feature allows users to have unique device identifier, generate and verify signatures for security boot. So if you are interested in our demo in Gowin FPGA, you can find it in the Experience Center. Thank you.
Oh, there you go. Can you control it? Got it. Hi, everyone. My name is John from Inspur. Today, just want to give update about our DCSCM usage in our actual product. Basically, the DCSCM 1.0 we adopted to apply to our next generation general purpose enterprise server. So basically, as you can see, the left-hand side will be the HPM, the normal two-socket motherboard, and then the right-hand side will be the DCSCM that we are going to deploy around next year for the next generation platform. So as you can see, the benefit about using DCSCM, so simplify the host motherboard and the management. I think it will help the development more quicker, time to market. And also we follow the spec of the 1.0, which is the form factor 90 by 120.4 mm of the module. So a little detail about the DCSCM module. I think you have seen so many different options in the show floor, but our design will be a little bit different in terms of the, for example, as you can see the right-hand side, the I/O port in the back, maybe you seem a little bit different than other people or other vendors. So there's some purpose of it because we need to implement the DCSCM into our platform. So there's some changes or minor modification from the spec to accommodate the motherboard and also accommodate our system. For example, we have to add the two USB connection to the host motherboard. And then also we added the JTAG for remote debug function through the XDP. And also we added the VGA port connection signal to the front because in our standard enterprise server, for example, in a 1U or 2U chassis, we do have a VGA port in the front, right? So we have to route the VGA signal to the front for end customer to take advantage of it to do system debug in the front of the rack instead of at the back of the system. So, and also we add the I2C signal to support the Intel PFR function to do the secure boot and measure boot functionality. And then, and then a little detail about that, right? So we support PFR and also have the dual BMC and BIOS flash, and also ideally, right, it's not necessarily based on a SP2600, could be other vendor of choice for our customer to choose from, and then take advantage of the DCSCM concept of it, right? So just show you a little bit about the serviceability, how the DCSCM module will be serviced in a standard server. So it pretty looks like a regular OCP NIC, but a different form factor on the same platform. As you can see, the platform on the left and right, you can see the regular standard OCP NIC on the side. So call to action, right? So DCSCM is real, it's happening, and will be ready from Inspur GMP enterprise server happening around next year for the next generation. And then for the next, what should we do, right? So definitely right now we launch with based on 1.0 specification. Definitely we will follow on to have a 2.0. We would like to hear more feedback from end user. Like you, right, to give us some comment, suggestion. What should we do, improve from 1.0 to 2.0? Definitely want to welcome to talk to you at our booth, Inspur. Thank you.